To complete our study of applications in section 2.3, we're going to consider one more shape. This one is also a three-dimensional shape. 2.3.4 deals with the volume of a cylinder. When we describe a cylinder, there's a couple of dimensions that we're going to recognize. Notice that the top and the bottom of the cylinder are circular. Therefore, there is a radius of the top and the bottom. The radius is the distance from the center out to the edge of that circle. Also recognize that if I look at the distance from, and I'll do this above, if I look at the distance from one end of the circle to the other end, that is the diameter or twice the radius. The other dimension of the cylinder that we measure is how tall, or what is the height of that cylinder. Once we know those dimensions, then we can calculate the volume of a cylinder. The volume of a cylinder is the area of the base. You'll recognize pi r squared as the area of a circle. So that's the area of the base, and then if we multiply that by the height, we end up with the three-dimensional volume of the cylinder. This problem will use that formula, and that will lead us to a quadratic equation. Example 6, the height of a cylindrical bale of hay is 5 feet. If the volume is 62.83 cubic feet, find the radius of the bale of hay to the nearest foot. So let's recognize the important information in the problem. First of all, we are dealing with a right circular cylinder. That's the shape that we have drawn over there to the left. And the radius, the height is 5 feet. We also know that the volume of this bale of hay is 62.83 cubic feet. And what is it that we're looking for? We are looking for the radius, and we need to round to the nearest foot. All right, let's see if we can set up our problem with a quadratic equation. We know that the volume of the right circular cylinder is pi r squared h. Let's plug in what we know. We know the volume is 62.83. Pi is approximately 3.14, but we can use the pi button on our calculator. The radius is unknown. That's what we're trying to find. So I'm going to leave that as r squared. And we were told that the height is 5 feet. So I can go ahead and plug in 5 for the height. Notice this is a quadratic equation. Pi is a constant. The variable here is r, and because it's raised to the second power, we have a quadratic equation in one variable. So my goal is to solve for the variable. I'm going to solve for r. R squared is currently being multiplied by two constants, pi and 5. So I'm going to divide both sides by those two constants, pi times 5. In fact, let me write it simpler. 5 pi. I'm going to divide both sides by 5 pi. And that's going to isolate the r squared over there on the right side. Now, we can rewrite the left side as the quotient, 62.83 divided by 5 pi, and this is equal to r squared. Now, do you know what to do next? Can you figure out how to solve for r? We have r squared equal to a constant, so we can solve with our square root property. We're going to take the plus or minus square root of both sides, but again, since we're dealing with a length, the radius is a distance, we're only going to keep the positive square root. So we're going to evaluate this with our calculator. The square root of r squared is r, and let's go ahead and approximate this to the nearest foot using our calculator. Now, big word of caution here, when I plug this into my calculator, it's very important that I put parentheses around that 5 pi in the denominator. Remember, anytime you have an operation in either your numerator or denominator, enclose it in your calculator in a set of parentheses. This will help your calculator to use the correct order of operations. So I'm going to evaluate the square root of 62.83 divided by, now I'm going to open up parentheses and enter 5 pi. So there's my 5. Notice over there to the right of your keypad above the caret button, you have a pi in blue. So I'm going to access the pi by pressing my second key and then the caret button. So your calculator stores the value of pi more accurate than 3.14. It keeps a few more digits than that. So I'm going to close parentheses for the denominator and press enter, and we get 1.99997. The problem said round to the nearest foot. That means to the nearest ones place, right? So we can round this to 2 feet. So the value of r is approximately 2. We have found the radius. We can say, therefore, the radius of the bale of hay is about 2 feet. That means the diameter is 4 feet. Let's double check and make sure that gives us the right volume. I'm going to go back to this original problem and we're going to plug in 2 for r. So I'm going to evaluate second pi times r squared, r is 2, times 5, and we should get approximately 62.83. Notice it's not exactly 62.83. That's because we rounded r to the nearest foot, but we have an approximate equality so we can be confident that our answer is correct. All right, this completes the lecture videos for section 2.3. You are ready to go and get started on your homework.